Good morning, everyone. My name is Evgeny Posenitskiy, and today I will present the first part of the Autotools tutorial, which will cover the part which is called Autoconf. So if you intend to follow up and do some time along, you can do it. There were some installation instructions, like things you may need for the tutorial. So it's basically a Conda environment with some packages installed in it. So it's like if you intend to type along, it's better to use this this Conda environment, or otherwise we provide two. The project that I will use as a starting point. So you can also download the tar.gz. It's also in the Autotools channel on Slack. And then the Autoconf tutorial will consist of two parts. So the first part will cover a bit like basic things. So how you can just basically start building your Autoconf project. And the second part is more about locating external dependencies. And so, yeah, so we will have a short break in between two parts. And then if you only intend to have a look at the second part, which is about the external dependencies, you can download what we call a checkpoint project. It's also in the pinned message, or you can follow up the progress that will appear on the screen, and then you will arrive to the same point as the checkpoint. Right. So so already yesterday, Christian Feld presented Autotools, and so we've seen what it can do and what it cannot do. So our task for this morning is a bit challenging. So we will try to convince you that Autotools are not that bad, and in fact, it has been widely used, and it will probably continue being used for at least for a while. So, right, if you had some issues with the Conda environment, please let me know. Also, I cannot have an eye on Slack, so if there are some questions, also please just let me know. So if you manage to download the project, what you will see is I unpacked it on my computer in the folder called like this, SM0.1 demo. On your machine, the name of the folder can be different. It doesn't really matter for us at the moment. So we chose this project because, as you saw yesterday, it's actually quite common that we start building our projects. So we start developing source files. Eventually, we accumulate certain amount of these files. So we want to link them together. So we introduce some dependencies. And yesterday we saw that as the project evolves, it's quite hard to keep track of these dependencies. And it's even harder to compile your project on different machines, on different systems. And then people have different approaches to that. Some people try to specify the compiler options in basically one big make file, which should sort of accommodate for all available systems. On the other hand, you can have a makefile per system. And so this is basically where Autoconf can help you. And Autoconf can be used to build makefiles for your machine. Basically, so when you arrive on some new system and you don't know the path to your compilers, you don't know where the libraries are located, this is where Autoconf comes into play and can be very useful for you. So for the demonstration, we will use the project called Sherman Morrison. It's a good example. And yeah, so maybe I forgot to mention that on Slack, there is also a link to this Autotools tutorial. It's a web page which consists of 2 parts. So if I go back for a second, so if you click the link that was in the Slack channel, you arrive here, which it's the web page which contains installation instructions, and then you see part 1, part 2. So you click on the Autoconf part. So here we are. And we chose this particular project, which was developed by our colleagues from TREX COE. I think Francois is here, so we are very grateful to him for sharing this project with us. So the idea here is that you can see the source tree here, but you can also visualize it in your terminal. Basically, if you unpack the tar.gz project that was provided, you end up with this kind of source tree. It doesn't matter the contents of the files at the moment. So it's useful to know that this is a C++ project. So that's why we have the .cpp postfix extension. And the important point here is that internally, these files depend on the library, which is called HDA5. And HDA5 is, again, without further details, it's a very powerful library which can be used for high performance input-output. And the issue here is that it's external library. It doesn't come with the source tree of your project. So we saw yesterday that locating external dependencies is a non-trivial task. And we will also see how we can configure our project, and we can also see how to locate the external dependencies, such as HDA5 in our case. So yes, we will see in this project how to go from your handwritten makefile. So it's you can see it on the right, but we can also open it in the terminal. I hope the font is big enough, but if not, please let me know. Right. The main point here is that what we would like to focus on is this first, oh, sorry, these lines here. So maybe I can zoom out so that they appear as 5 lines. But you can also see them on the right here. So the main project problem here is, well, it's not really a problem, but the main issue here is that we have a well tested sequence of flags for GNU compiler. So this sequence was designed for being used on Ubuntu machine. And so if you have installed HDF5 with apt-get, you will be able to compile this project on your machine. However, if you activated the Conda environment that was provided in the Slack, if you run make now, you will get a lot of errors. And well, we won't do this now, but believe me, it would be almost impossible to debug these errors. And the main reason why is because these errors, they're not like problems in the source code, but they originate from some missing dependencies and from some missing standards. And so it's very hard to debug these things. So so if we now come back to the makefile, since we are in the Conda environment, it's actually might be useful not to override the existing flags, the one we see here, but maybe instead of using equal, we can use the so in GNU makefile you can use the plus equal, which is should correspond to appending to the existing flags. And here the thing is that we chose the names rather wisely, because these are the names that are default names. And so what might happen is that your environment, in our case it's Conda, maybe our Conda environment already preset these values, but we have overwritten them. So we've lost some information provided by our environment. And so in order to avoid that, we would rather prefer to append to the existing flags. So
I have a question.
Yeah, sure.
I thought that the values specified on the command line of CXX, for example, overrides the value specified in the makefile.
Values provided by
the values that is in the environment has a higher priority than the value specified in the makefile. I thought so. I thought I remember that.
Well, that's a good point. At least maybe the values coming from the Conda environment do not have this priority, but
well, if they are environment variables, they are just environment variables.
But we just show in the example that it was not the case, and so maybe you're confused by the fact that you can run make CXX equals something, and if you pass it on the command, if you pass the CXX flags on the command line as an argument of make, then it will override them. But I'm not sure that the environment variable will be will have a priority, because on the example Evgeny just showed, it was not the case.
Okay, thank you. Maybe I'm wrong. Okay.
But, I'm going to check while he's doing it. I'll give you the answer in a few minutes.
Yeah. So also in my experience, usually the values that are specified in the makefile, they kind of override. But okay, maybe Anthony can verify at the same time. Sorry, where I was. So I should note that I should mention that from now on we will only work with these 5 lines. So we will not touch the rest of the makefile. So yeah, so if you follow the tutorial on the web page, you will not see the remaining part of the makefile. So let's remove these flags for the moment, the two flags that were specific to GNU, to this -G and that O2. And let's remove these paths, which were hard-coded for the Ubuntu machine. And then here, well, we can leave some of these flags, but actually not all of them are necessary. So yeah, and then, so we know where the lib libraries are installed on our machine. So actually since we are in the Conda environment, they are located in the Autotools -lib, but then the path may be different on your machine, so you can replace user with the name of, with your name, the name of your machine. Right. So we have modified it. So what happens if we run make now? Yeah, just before I cleared the terminal, so it's not crucial. Yeah, so we see that everything compiles now. And the reason for that is because we have now we have appended to the flags provided by the environment. So in particular, what you can see is that we have these things that we have not specified in our makefile, but they appear in the list of the compiler flags. So it locates the include directory of our Autotools environment, and then it also adds the fpic flag. So these are the things that were provided by the Conda environment, so we have them included, and the compilation works. So the question for you, what would happen now if we try to, so the makefile that we've just modified, if we use it outside of the Conda environment, what do you think will happen?
We will miss the flags that you removed.
Yes. So you will actually yes, you will miss these flags that were provided by the Conda environment, and then the compilation will not work because you will be missing some of the files that were installed in the environment, but they are not installed outside of it. So this was just to show that even though this carefully designed and well tested sequence of flags on one machine, it may lead to a lot of issues on a different machine. Yeah, that was probably a long introduction. So so let's now move to the Autoconf. And we've seen yesterday the several tools that are present in the Autotools, let's say, family. So here I will only focus on Autoconf, and the goal of the Autoconf is to produce the configure script, and the goal of the configure script is to produce the makefile. So this is a bit of like Matryoshka problem. So you can see this figure here, which represents the kind of the typical workflow that you might have, where you basically have Autoconf, which which acts based on configure.ac file. And this AC file is just, it's a bit like what we've seen yesterday with CMake lists. It's this file contains a list of commands that Autoconf can, it's a list of macros actually. And Autoconf can process these macros to eventually produce the configure file here. And this configure file then takes as an input some kind of template, which has a .in extension. And .in, it's you will see this extension quite frequently in Autotools environment. And finally, it will produce the make file. So the thing is that to initialize your Autoconf project, all you need to do is the following. We just, in our directory, we create a configure.ac file with the following contents. So this is the minimal kind of setup that you need. Sherman Morrison is the name of our project. The second argument in it is the version. Here we use semantic versioning. And the third argument can be a link to the web page, for example. So you will see a lot of this AC underscore prefix. So these are the macros that Autoconf can understand. And just like CMake, Autoconf is also based on it's largely based on calls to these macros. And the syntax is a bit painful. It's based on the M4 language. And probably most of the time you won't need to dig into details of the macro. And anyway, I guess in 3 hours that we have, it will be impossible to cover the details. But we provide some literature on the main page, so you can, if you're interested, you can have a follow-up. So we know that our project is a C++ based project. So we can include a couple of Autoconf native tests. So for example, first we specify that our project is based on C++ code. Then we will try to, this AC prog will check the C++ compiler. It will execute a number of tests. And we will also check some additional compiler options. And from now on, we can actually add this kind of debug output, which will basically it will print the things that Autoconf can locate. So in our case, for the moment, we're interested. We would like to see what compiler it can detect and what are the default flags of our environment.
Can I ask a question?
Yes, sure.
Do you agree with what was said yesterday that the Autotools are not convenient for a Fortran program?
They are not convenient. They are not convenient in a sense that I don't think they can locate what Radovan showed yesterday, that it could detect that one module file depends on another one, and it will compile it will create this dependency. So this Autoconf cannot do. I think you can do this manually in the automake part, but this is second half of the tutorial, so but then you will have to specify manually the dependency, I think. I don't think that Automake can detect them for you. But all the rest, I think, for testing Fortran compilers, for detecting Fortran libraries, Fortran dependencies, this Autoconf can do. And you can specify, instead of having C++ here, you can specify Fortran. And there is a number, there's actually a vast amount of macros available to test for Fortran compilation.
Okay, thank you.
So basically, as Christian Feld mentioned yesterday, probably the main command that we will keep using very often is this autoreconf. And the reason is that this command is used to regenerate configure script if it already exists. And also it can be used to generate it from scratch. So this is the command that you will use most often. We will add -i to it, which is short for install, just in case if we are missing some files. Autoreconf will install them in our directory. So if we now examine the directory, we see that we have a configure script, which is executable. So let's try to run it. So you see that there was a number of checks performed. It checks that the C++ compiler works. It checks that it's the GNU compiler or not. And then, so this is basically our summary, the one that we printed with echo. So you can see that what we detected is that the default compiler in our environment was the GNU compiler, but it's the one installed in the Conda environment. And then we see the default C++ flags that came from the Conda environment. So that's already pretty good. And then you can actually you can access the variables just like you do with the shell variables in your scripts. So for example, if we come back to configure.ac file, you can see that in order to print the detected values, we just used $ and then the name of the variable. There is actually so we use the default ones because these are detected and modified by the Autoconf, but it's the same as the ones we used in Makefile. And then now basically the main, I will clear the terminal. So now comes probably the most important step of your transition to Autoconf. So now we can actually propagate the values detected by Autoconf. We can propagate them to our Makefile. But to do that, we will have to copy or move our Makefile into .in file. And we will replace, instead of having G++ here, let's put @cxx @. So this is the syntax. Whenever you see this, the variables that is in between these @ symbols, it's what is called substitution variables, and these are the variables that can be basically that they are substituted by the configure script in your makefile. So again, here, since we detected some C++ flags, you can see them here. Right. So we will not modify the rest for the moment. So also, if you follow the tutorial webpage, you will see it also here. So now, one tiny change that we have to make in our configure.ac file is we now have to tell it that the makefile will actually be produced by the configure script. And this can be done with ac config files macro. So we tell it that basically now it's responsibility of Autoconf to generate this makefile. So again, whenever we say that we have to reconfigure, basically it's this combination of commands. We do this and this. So auto reconf, again, it will regenerate .configure based on the new changes, and then .configure will actually configure the project. So let's have a look now at the differences between makefile and makefile.in. I will use diff for that, but you can use vimdiff or whatever you prefer. So we see that in makefile.in, we had these substitution variables that have been now replaced by the values coming from the conda environment. And these have been detected by the autoconf. So actually, this is all you need to do if you want to start using autoconf in your project. Of course, there are many more substitution variables, and you may use to define them yourself, and we will see how to do it later. But for now, I just wanted to show you what you can do, the minimal example of what you can do and how you can configure basically how you can propagate some basic stuff from your configure script to the makefile.in. And actually, we missed one compiler flag while making the transition. Do you can you spot it? It's an open question. So if you don't hesitate to answer if you want. If not, just we'll wait a few minutes.
CPP flags?
It was the C++ flag that we missed, but not the CPP flag. Maybe I can open the makefile.in on the left so that it's actually what we missed was one value in CXX flags, which was not important here, but we actually forgot to specify what was specified before, that our standard of C++ is C++11. So, so it was this flag that we were appending. The thing is that it was not important on our machine because our compiler already had this standard, but on some older versions of C++ compiler, you might have to add it because some older compilers they have older standards, and then your code will not compile. And well, again, it's maybe not that important here. But also there are macros for that. So if you want to configure for specific compiler flags or compiler options, you can do it. Yesterday there was a question about the Fortran, like whether like configuring for particular standard of Fortran. Autoconf can also do that. It can also check whether a compiler accepts the freeform Fortran or Fortran 90. Then I think the first part pretty much done. So we can maybe, if you have questions, please feel free to ask them now, or we can have a short break and then we will move to locating external dependencies.
So the fact that you specified in the libs variable, you specified, for example, LZ, you have to know that the configure tool cannot find out for itself that it needs -LZ.
We will come back to this because this is because as you can see here, on purpose I leave everything related to HDF5. So we will see that Autoconf can actually it can actually properly assign all these other flags related to external dependencies. But it can also be done with package config.
Evgeny? Yeah.
Yes.
Can we have a multiple flag declaration like within the symbol on one line? Let's say you have @CSX flag, and let's say if I have some other variable, let's say something CPP flags. Okay, can I write that on in a single line?
When you substitute like this,
yeah,
I think you can. We can try. I think it's possible, but I think it's better if you maybe create the variable separately, because I've never seen it that way.
Okay.
But maybe it's better especially if it's some default names, so you assign them, and then if you want to build a variable from them, this you can of course do it. But just out of curiosity, I will try right now.
So it's going to work because the makefile.in is just a template, and then what's going to happen is that the M4 is just going to replace the variables between the @signs by the variables in the configure. So you can also using this system, you can write even something else different than the makefile.in. You can even write some code or a Python script or whatever with the @sign side, and it's just a template.
I see.
Yeah, I was trying to append the variable that was empty, so obviously nothing was appended.
So the big difference with CMake is that CMake is something which is quite simple to dig in, and so but here it's a bit more complicated to understand how all this works. But you have a huge flexibility, because at the end you just generate shell scripts. So you can really fine tune it. You can do exactly what you want with it. So I don't know if you have that amount of flexibility with tools like CMake. But if you want to have an infinite flexibility, then it comes with a cost, which is probably a higher barrier to learn how to use it.
Okay, so then if there are no questions, we can have a break. So I don't know, Anthony, what do you say? 5-10 minutes? 10 minutes?
Yes, what time is it? Let's say we come back at 9:50.
Okay, okay. So see you in a bit. So, welcome back, everyone. Not everyone.
Evgeny, I put on the Slack a few answers to the questions that were asked this morning. There was one about Fortran dependencies.
Mm-hmm.
So I put a link to a tool that can generate automatically Fortran dependencies, and also a web page where all this Fortran module problem is explained, and how to make some makefiles that will track these dependencies quite well.
Okay, good. Thank you. Yeah, and I saw that for the makefiles, actually it makes sense that, I mean, that when you define variables in makefile, that they override the ones from the environment, because that would be the whole objective, right?
Yes, yes, yes.
That you basically you provide your own compiler flags and all that.
Yes. So it's really if you pass them as an argument of make.
Mm-hmm.
But it's confusing, because if you put them before make, then you set them in the environment, so you can be confused between the two ways of doing things.
Yeah, that's why actually maybe you should always modify them at configure time and not at make time.
Yes.
Well, yeah, I think we should probably start, because we don't have much time. It's hard to say if people are back or not, so I hope they are. Okay, I see Johan. Good. Well, I will slowly start, and then people can catch up, because we're now entering the part which I think is one of the most important about Autoconf, and it's about locating external dependencies. So basically, if you didn't type along, you can always just download the Checkpoint project, as I mentioned before. So there is a link here. There is also a link on the Slack channel. The Checkpoint project already contains a few files that I will explain now, or otherwise I will try to incorporate them online, let's say. So basically, so far we discussed how we can do some basic configuration checks. Check the compiler, check some compiler flags, print the output, and we also saw how you can take your custom makefile and then how you can incorporate the information obtained at configure time in this makefile. And this is done by basically using substitution variables. So now what I would like to show you is the part where Autoconf locates external dependencies. And of course, you can write your own macros, which will be just a combination of M4 and some default Autoconf things. But this is quite often challenging and involved. And instead, there is also, Christian mentioned yesterday that there is this Autoconf archive. So we have a link here in the tutorial. You can click on it. And most of the time, if you're using the library, which is quite common and widely used, what you can do is, instead of writing your own macro, you can go to this website, and maybe there is already something. Oh, wait. Maybe there is already something there for your dependency. So, for example, if you're using BLAS, then the chances are there is a macro to detect BLAS. Also, now, since we are looking for the HDA5 library, well, yes, there is a macro for that as well. And the good thing, and it's the same for CMake, as far as I know, that it's better to use these macros because they have been, let's say, battle tested and they're maintained. So whenever you get an update for some exotic system or for some new compiler, the chances are you will get this macro updated. Otherwise, the burden is on you as a developer. And well, this is not always this is not always desirable. So let's click on this file. You also have the link in the tutorial. And what you can see is quite a detailed description of this macro, what it can do. And another powerful feature of Autoconf is that it allows you to perform optional compilation. So you can basically specify whether you want to compile with or without certain dependency. So in our case, it's HDA5. And an important part here is this this part of the description of the macro. It says that if HDA5 is successfully found, the macro will define all these variables. And you see this, it has the subst prefix. And this is because actually all the variables that are defined, that are provided in the brackets, these are the new substitution variables. So we saw before how we can propagate things from configure to make files by using substitution variables. And this is also the case here. And moreover, these variables will be defined and can be used inside our configure.ac file, just like we use shell variables. So basically, well, there is a more detailed description. You can also configure for parallel HDA5 or serial, but this is not important for our example. So again, it may be a bit confusing, but there is nothing for C++. There's no CXX flags here. And this is quite often the case. So very often you will see that actually the C flags, if they go into the C++ flags. And so this is just important to keep in mind here. Well, this being said, now we know where to find this macro. And it's it's usually considered a good practice to put, because we can now use this external macro by copying it in the source tree of our project. And it's usually a good practice to create an M4 directory called M4, which, as we talked before, it's the language which is used internally by Autoconf. So we create this M4 directory, and we create an axlib HDF5 M4 macro in there. Then basically what we can do, we go back to the web page. There is this link, download the latest version. Let's click on it. So we cannot download the file on our machine, but instead we can just manually copy it. So, and again, if you downloaded the tar.gz of the project, you already have this macro inside. Yes, Leonel.
Yes, just out of curiosity, how does it, just to have an idea, how does it find out all this information? Does it depend on pkg config, or does it run an HDA5 command?
Yeah, so it looks for the, actually we can have a look here. So it does not run package config at this point, but it will try to locate the HDF5 by running a number of tests with it, and a number of common paths like that. Maybe I can find it here. Wait. Because this is what it often does. So this is how you can check for like library or header. You use this AC check macro. Yeah.
So the AC check macro or checklib that takes into account the value of the LD flags, and I think a few lines above the LD flags are set to a specific HDF5 directory that was somehow evaluated before by looking at some programs. So there was an AC pass procs, for example. I think maybe here we check for some passes, and if a program is in pass, then use this pass, remove the trailing bin, and take this and add and lib, and then use this as LD flags and check if you can find or link a library that is in this this pass. So this is the usual way. Somehow provide an a directory, and then set this directory to the LD flags, and then perform the actual check.
Yeah, thank you, Christian. So yeah, so at this point, we will see also if we have time later, we will see how we can use package config, just in case if the macro fails, which didn't happen very often with me, but there are some situations where this might happen. So it's good to know. Right. So now we have the macro directory and the macro inside this directory. So we go to our configure.ac. And we have to add the following two lines. One of them tells that now external macros can be located in this directory called M4. And then we add the actual call to the HDF5 macro that we just defined. So just one important point here, it doesn't have the AC prefix, it has the AX prefix. And this is actually the capitalized name of the file without .m4 extension. And so we just add it like this. And remember how we saw that this macro, if the library is detected, it will define a number of substitution variables. Well, so now we would like to actually have a look what these variables are. And since we need HDF5 for our project, we will actually append these detected flags to our default flags. So the LD flags, the CPP flags, etc. So for this, you can copy actually either the full autoconf, either the entire file, which is here, or basically you can have a look. So there's this part here. Let me copy it first. Basically, if HDF5 is not found, we would like to raise an error because we know that our code depends on it. And so we know that it will fail if the HDF5 is not present. So, so we can warn the user before actually configuring the project, which is a good thing. Then, as I said before, we will we will prepend our flags, the ones detected by HDF5. So you see that here we just use the shell variables. We use them as shell variables. And some things are not always detected. For example, we have to manually add this HDF5 CPP to indicate that we will also use the CPP API of the HDF5. But we will see already that macro will do the quite decent job locating things. And then now let's make a more verbose summary of things detected by HDF5. So before we were only printing CXX and CXX flags. Now we will print. Now we will print all compiler flags. Remember, now we have them. We have modified them with HDF5 things, and we also want to print some information about HDF5 itself. So we can print the version, and we can print yes or no for the, like, whether we compile with HDF5 or not. And well, remember in the makefile.in, we still have these hard-coded things. So let's remove them. And basically we can now, what we can do is we can replace these things with the substitution variables that hopefully will be properly modified by our configure script. And that's the only thing you have to do. As you can see, all the hard work, all the heavy lifting will be done by the configure script. So let's reconfigure now. So we run autoreconf and then .configure. So we see that it takes a bit more time, but in the end, we have detected HDF5, which if you run this tutorial in the Conda environment, you should have the same output. So you will have the version 1.12. This is the one installed with Conda Forge channel. And yeah, so we see that the macro detected that HDF5 is located here. And I think it was Lionel who asked earlier about adding LZ manually to the libs. So we can see that now the libs string is quite long and it contains more things that we actually specified. And this is because the macro itself, the M4 macro, it detected what things might be needed for HDF5 and it adds them to the libs. So even though you don't use, even if you don't use them explicitly in your code, it adds them just in case, so that like if later on your code evolves, so that you don't have to redo it again, so that you don't have to basically look for missing libraries and stuff. And well, we can actually check that our code compiles. I will have to do make clean first and then make again. Yeah, well, it compiles. Already good thing. So I know it might be a bit difficult to debug this compiler, compiler sequence, because now it contains these very long lines of flags. But we had to do it in the Conda environment so that it will be the same for all the participants. So basically what I will ask you to do now is I will ask you to configure again, but using without HDF5 syntax. So like you see here, or it can look like this without HDF5, or it can be also with HDF5 equal to no. So, so if you have successfully reached this point, you can run this command and just let me know what's going on, and in your opinion, which part of the configure.ac file is responsible for it.
Evgeny?
Yes.
Could you just show what you obtain when you run configure out of the Conda environment?
Yes. And if you need this, it's also present here on the web page. You can also see the output. It just, you will have to scroll a little bit. And I saw that I think Christian posted something. Yeah, I do agree that we could have used also a macro to detect C++11 standard, but it's not built in, and I didn't want to go again to the GNU archive. But thank you, Christian. Yes, it's actually a good approach to do this. So did you try to run
Yeah, it raises an error when you reconfigure without HDF5 because it's a requirement.
Yeah, exactly. Thank you, Francois. So yeah, if we come back to the configure.ac file, well, maybe I can show you here. I will clear. And actually, we don't have time for that, but you can use this later on. And so basically, you can have the optional compilation of your code. So you can use the preprocessor macros to actually basically decide whether you want to compile certain blocks of your code. If, for example, if you use HDF5 library for something, you can basically wrap this usage of HDF5 inside this preprocessor macros. And then if HDF5 is detected, this code will be activated, it will be compiled. Otherwise, it will be just skipped by the compiler. And this is actually very useful, and you may want to do this with MPI or OpenMP, but this is a bit beyond the scope of our time limit. So so if we run now without HDF5, we get this error. Configuring with the HDF5 library is required to build this project. So this is good because at this point, if the user downloaded the tarball of your project, and if for some reason he doesn't know the requirements, he doesn't know what's installed on his system or not, you can actually tell him, and then you can provide, the user can decide for him or herself what to do later on. And yes, Lana.
It's a bit strange that there is an option without HDF5 and there's not really an option. It's not really an option because it will stop. It's strange that it creates an option for something that's not really available. But yeah, okay. Just a remark.
It's create
the option without HDF5. If you have it, you would think that it should work with the option if you have the option.
Yeah, but you try to configure your project without the library. So even if it's present, you don't want to use it, right? So, for example, if it's some heavy library and maybe you don't always want to include something that, but maybe I'm not clear.
So if I can answer that one. So the with or without HDF5 option comes from the backrow that's provided in the M4 directory, and so this is provided by HDF5. So HDF5, they have prepared everything to set up all the environment variables, and also an option if you want to activate or not HDF5. So that there are some projects that enable the possibility to use HDF5 or not, because you can always say, well, if I have HDF5, then I use it to store files, and if I don't, then I use another backend. And so this is provided by the axlib HDF5 macro. So here, Evgeny just put it in the example just to show how we can deactivate it, but because it was easier than to change the path and to make HDF5 unavailable, to trick the system to make it unavailable. Do you understand? Is it clear?
Yes. So you could not remove the option, for example, from configure, or it would be complicated.
So you would have to redefine the with HDF5 as something that doesn't exist. So it's something we will see probably in the next section, because in the next section, if we have time, I will present quickly these with and without options.
Okay, thank you.
Yeah, Ravindra?
Oh, yes. So if you go to this configure.ac in the if condition there, yeah, you suddenly have small caps with HDF5. Does it matter? The case matters there, or?
So this is the syntax. So this is the syntax of M4, and actually, so you see here you also actually have to prepend using X, and then you X no. So it checks if the value of HDF5 is exactly no, then it does something. Otherwise, so here I think the case matters, but yeah.
Yes,
I think it does. Yeah,
it does. It does. It's because it transforms into shell.
I see.
And so at the end, this you have here on your system, you should have a test program that just tests an expression. It's easier to write it like this than in shell. And also the origin of the X is because if with HDF5 is an empty variable, then in the shell you would have if test nothing equals no, and this would crash because you wouldn't have the first argument. So by just putting the X, you protect yourself from having an empty with HDF5 argument. And it's very common to see this kind of practice in configure file, but you can do the same in bash scripts.
I see. Yeah, and whatever follows with underscore is the name of the library. So let's say if I want to check with BLAS, I'll have just with underscore BLAS there, right?
Well, for this you will have to check the macro, because you see here, if we come back to the description, it says that the macro adds with HDF5 option with one of the three values. And then you should check. Normally, this is how it works with other macros as well, but you should probably always check the description.
I see.
And I'm running a bit out of time. Sorry about that. But so, as I mentioned before, you can also basically use package config inside Autoconf. As far as I know, it doesn't have the full functionality of package config, because when you call to package config, you can have this. So you can have this basically package config C flags, and then you have only include flags using this only I. So this is not present in the Autoconf, but nevertheless, you can use what is called package check modules. So this is a macro, an Autoconf macro that you can use to basically try to locate a dependency with package config. So in our case, we will, yeah, it's here. So basically we will try to locate it with this macro call. So, and actually the good thing about using it like this is that you can also specify the minimal required version, which was not possible in the M4 macro that was provided in the Autoconf in the GNU archive. So here we can actually specify that HDF5 has to be not older than 1.8. So now we take this line and we go to our configure.ac script, and let's put it, at this point the order doesn't really matter, as long as you always have to put the Autoconf macros between AC init and AC output. So it's kind of like it's working like this. And then, so we added this macro to detect the check modules. And then if we now try to reconfigure, what will happen? So we run autoconf again, and then .configure. So surprisingly, it fails, and it says package requirements were not met. No package HDF5 found. So this may happen, and the reason is that since we actually installed HDF5 in our Conda environment, the package config path variable that is used by package config to locate the library, it doesn't know that we're inside the environment. So one thing you could do is to modify it, and well, you can actually manually modify this as a shell variable and say that you can append another path where to look for the HDF5. But since we already know that actually HDF5 was located with a previous macro that we used, you can use you can add a warning, and this is basically another powerful functionality of Autoconf, is that for the big amount of Autoconf macros, you can specify actions to be taken if the macro succeeded. For example, if it found a file or a library, you can specify an action to be taken if something was found or not found. So, for example, in the case of package check modules, this is how it looks. Remember, if I now come back to the configure.ac file, I know it's here. So remember here, we just specified two arguments, basically this one and HDF5, the minimal version to look for of HDF5. However, we could have provided also two other arguments. These are optional, so that's why they were not requested by the Autoconf. So here we will trick a little bit our configure script to say that basically if the library is not found, if HDF5 fails to locate the library, well, what we can do is we basically just raise a warning and not an error, because it has already located HDF5 with the external macro that we use. So fortunately, that was normally this would be an exercise, but we don't have time. So I think I should do it just. Yes, Leonard.
So I don't understand. You have two things that do the same search. You have the AXP by HDF5, and now you added the PKG check modules, and these two, they are in competition. Which one? I don't understand. Which one has priority?
They are actually, it's better to use both, because there are some situations where the macro will not detect the HDF5. So for example, if it's installed in if it's installed locally in some directory, and if it's not present in the path, then this macro will not detect it. But there are some cases where if you're using library which depends on HDF5 and which has package config for this library, then you can have the package check modules will actually help you. So you ideally, like what you can do here is that you can make an optional sequence basically. So if this macro has not detected anything, you try to proceed and use package check modules. And then if package check modules fails, you raise an error. Because there will be cases where this macro will not detect HDF5, but the package config will. I think if you want to have a real example, maybe during the break I can show.
But suppose they don't find the same thing. Suppose they both find something, but they do not find the same thing. For example, one finds something in the conda environment, and the other one finds something in the package of the. Which one has priority?
The priority. Well, you decide, because at this point the flags, both macros, they will define some variables, some compiler flags, and it's up to you to decide which ones to use. So, for example, you can say that I will only append things coming from this macro, and if something comes from this macro, I will check what that is, or vice versa. So by default, everything defined by the autoconf macros, it doesn't go anywhere. It's you who decide where to put this, like what we saw before, that the macro defined this HDF5 C flags and Cpp flags. And so we decided to include them in our compilation flags. But we could have just, I don't know, printed them without using them explicitly.
Okay, but package check module doesn't define the same macros.
It will define the same variables, yes, but only if you actually there is a link here to the Autotools Mythbuster, and it will only define these two things, only these two variables. But the foo here, it's what you provide here as the first argument. So if I replace this with something like package HDF5, this macro will define package HDF5 C flags and package HDF5 libs. And then this will not be in conflict with this, with the variables defined by the macro. And then you can use them. You can actually, if you want, you can just append both, but that's not very safe, as you said, for the case if you detected two different installations.
Okay.
Also, it's safer to check first for the AXlib HDF5, and then if it fails, check for the package config, because if you have two different or multiple versions of HDF5 on your system, with the macro, it will provide the with HDF5, and the argument the with HDF5 can be the location of the library. So the user can specify on the configure command line which HDF5 he or she wants. So it gives more flexibility. So if you don't say anything, then it will try to find the default. If it fails, it switches back to package config. And then if the user provides something on the command line, then you give the freedom to the user. Because if you try to check with package config first, then you might lose the possibility for the user to give it on the command line.
Yeah. So again, normally this would be a bit of type along, but unfortunately we're running out of time. So just as before, we use this ACMSG error to raise an error. Here we will use we will raise a warning, and for this we will use the oh, actually I made a typo. So we will use this macro here, ACMSG warn. So you see now we appended two additional arguments. As I mentioned before, the first argument is action if found, and then the second is action if not found. And then just to visualize what it does, basically, okay, like you already remember like how it failed last time. And so now we reconfigure. And yeah, well, it's a bit hard to detect the exact warning, but you can always use grep and something like this. The main point here is that it actually raised a warning, but it allows the configure to pass. Of course, as we discussed before, it's up to you as a package maintainer, as a project maintainer, to decide what you actually what's going to happen in this case. But I just wanted to show that you can also raise warnings without actually breaking the configuration sequence. And I think that's pretty much everything I wanted to show. I hope it was clear enough. And then I just wanted to show with this example how you can, with, I would say, not much effort, make a transition from your custom handwritten makefile to something which is configured with Autoconf. Yeah, I don't know if we have time for questions. Anthony, what do you say?
Yes, we have time for questions. Always. Or we have time for a break.
Which is also good time.
So we're a bit short on time, so let's say we start again at 10:40. Okay, so this second part of the tutorial will be on the usage of Automake. And so before we dive into Automake, I'll try to explain to you a little bit the context in which it has been used, and you will see in the end that it's going to be much simpler than what Evgeny has shown you. But to understand Automake, you need to see how the makefile.in works and how all this works. So Automake, what is it? It's a simplified syntax of a makefile that's going to produce some standard makefiles. And what I call standard makefile is a makefile that follows the GNU coding standards. And so this implies that the names of the targets are standard, and also the names of the path where you will install the software are standard. So this means that you should be able to call make install, make clean, make list, and all these standardized names. And also for the paths, USR bin, USR share, USR include, etc. So if you look at the figure below, you have a figure of how all these tools operate. So Evgeny has shown that you write the configure.ac, then using autoreconf equals this set of tools in a black box way, and it produces the configure script. And running configure with makefile as input will produce your makefile. So what we'll introduce now is the makefile.am file that's going to be read also by autoreconf. And now autoreconf will also call automake to build, using this simplified syntax, the makefile.in. So you will not have to write it yourself again. And then it will also produce the configure and the makefile. So what will be seen in this section is just how to write this makefile.am in such a way that it's going to produce this thing for you. And this makefile.am will provide much more functionalities than what we have seen in the previous section. So before talking about makefile.am, I will talk about all these standard standardization things. So first, the GNU Codex Standard. So there is a document for this. You can click on this link. It's a set of prerequisites that your package should have to obey these standards. And why is it important to follow these standards? Well, it's because there are so many GNU packages on the available today that if you follow the same standards, then your users will know how to configure and install your software without reading the documentation. And as you all know, users never read the documentation, so it's better to find a way that they will be able to install your software without reading it. Also, another advantage is that the packaging software to make Debian packages or RPM, they are very well adapted to software that's packaged with Autotools. So if you go to the end of this tutorial, normally what you have at the end is something that you will be able to make a Debian package or RPM, or even a homebrew, Wix, Conda, Spack, whatever kind of package very easily. So that's also a good motivation to use a build system, and the same applies to CMake. So about standardization, we have standard targets. So I put here a list of the principal standard targets. So we have make all, that's supposed to build all the targets. Make clean, that's supposed to remove all the produced files. Make check, to run the unit tests. And so we have seen here a difference with CMake, because yesterday it was make there was a make test that was in the files. So in the GNU standard, it's make check. Make install, to install the package. Uninstall, to uninstall. So this is it's important also to provide make uninstall, because you can expect the users to want to remove properly what your software. Make HTML, to build the documentation in HTML format, or make check. So make check, I put it twice. So you have make this to make a distribution. And so if we look at the project we have taken here, we see that the developer of this software has put the all target and the clean target. So there is so you see that this person wanted the users to naturally know how to remove the object files by running make clean, because all this is very mechanical. So it's part of the GNU standard. So second important standardization is the file system hierarchy standard. So this is really the definition of the directory structure that you have on Linux distributions, and well, all Unix-like systems. So you can the web page on Wikipedia is very well done, because it's concise, and you have all the information. But what you need to understand is everything you have at the first level of the slash is are the things that are really essential. And so under /bin you have the essential binaries like ls, all these programs that are really essential for making your system work. etc is the editable text configuration file. So this is where you have a configuration of the machine. Sbin for so essential system binaries. So these will be essentially binaries that need to be run as root. Share our platform independent files, like documentation and all these files, icons or things like that. /tmp is standard also for temporary files. And then you have the /usr directory, which is a second hierarchy for user data. And so inside you have the same kind of directories as those ones: usr bin, usr lib, include, etc., which are non-essential for your system. So typically, it's what you will install on your machine after the minimal installation of the system. And then you have a third level of hierarchy, which is the USR local, where inside this is where you will install the software that that is really installed by the user. So, for example, USR bin, you will have everything that your package manager will install everything there. But when you download some software and you want to install it and use this particular software instead of the software provided by the package manager, it will go in USR local bin. And this path is supposed to have priority on USR bin on your in your shell configuration. And the same apply for USR local. You have USR local bin, USR local lib, share, etc. So it's important to have this in mind. Yes, Lionel, you have a question?
So basically the difference is with or without the package manager between USR and USR local.
So that's the idea, but you can also, if you want, install software in USR bin. But this means, well, it's not supposed to be a good practice to do it this way, because if somebody, if you log in on a machine and you see it's a Debian with a version whatever, and you run some software which is in USR bin, you expect it to be the version provided by the distribution. If it's in USR local, you know that it's some custom version. But you can do whatever you want, but it's better that you don't put your software when people run make install. It's better if they install it in USR local or in some other location than USR bin. USR bin is really reserved for packaged. So yes, so you're right, but it's possible. It's always possible to do differently. It should be the guideline. Okay, so we have seen the standard target, standard locations, and now standard variables that are in the makefile.in. So all these installation directories, they have a variable. They should have a variable associated with them in the makefile.in. So prefix by default is USR local. So it's really the root of the hierarchy where you will install your software. Exec prefix will be the root for executable files, and you then have also a variable which is called bin_dir, and so this is exactly by default exec prefix followed by bin, and so by default it will be USR local bin. The libdir variable will be exec prefix lib, so it will be USR local lib, etc. So you have variables for all these important paths, so that it's possible to change them. You can really pick one of them and change it if you want, but then also you can really set the prefix and say, well, I want to configure my package to be installed in USR local, or I want my package to be installed in /.config, for example. You can do whatever you want, and then all the install procedure will be the same. What will change is just if you change prefix, it will just change the root. And if you're on your system, you have a special place where you want to put all the documentation of your package, then you can set prefix to USR local, and then you can just change the doc_dir also if you want. And so in the makefile.in, all these variables will be between the @ like we have seen in Evgeny's section before. And you can change these variables. They all have a -- argument on the command line. So if you want to change the prefix variable, then you can set it with configure like this. And if you want to change the configuration directory, which is by default etc, you can change it like that. So here I put a link to the documentation for directory variables. Okay, and so the last standardization part is about these environment variables that we have seen. So if we go back to our makefile here, we have the CXX, CXX flags, CPP flags. So all these are compliant with the GNU coding standards. And so it was a good idea from the original developer to put these variables in the makefile. And it's also these variables that are going to be set by the configure, as we have seen previously, and all the Autoconf macros that you will download on the web, they will all change these this set of flags. And also, when you need to know the names of these variables, because in Automake they will also be used. Lionel, yes.
It's strange because the Fortran compiler flags variables that make knows is F flags and not FC flags. The
Yes.
default database of make.
Yes, yes, and so so maybe somebody has the answer, but I think that F flags is for F77 and FC flags because FC.
Yeah, exactly that. Yes.
I would say that it's F90.
Yes, it's that. It's for Fortran 77.
That's not true because make doesn't know the difference between Fortran 77 and Fortran 90. It just has a rule for the Fortran compiler and F flags. It doesn't know anything else. It just has FC and F flags. It has nothing else.
Okay. And also, I would say that it's a bit inconsistent because here you have CC, which would be C compiler, and FC F compiler. So you expect C flags and F flags, not FC flags. It's not natural. Evgeny, can you check when I'm speaking if there is an F flags in the Autoconf in the GCS for just to check if because maybe there's a difference between F90 and F77 in Autoconf. This is for sure, but maybe it's not in Make, and they have some kind of workaround in the background that transfers FC
yeah,
flags.
I'm checking it now, but
yeah.
Also as far as I remember, like it changed over time. So it also depends on the version of probably GNU Make that you use, because at some point it was F flags and then it became FC flags. So, but I'm checking.
Yeah, it's F flags in the current version. This hasn't changed.
Okay. Okay, and so so if you have defined in your so here we have defined the CXX variable here inside the makefile. So if I run make make clean and make. What did I do? Oh, make. So it compiles the software using the this thing that has been set by the configure of the we have seen before, and we can see now that if I do make CXX equals G++, it will run G++ instead of the C++ compiler provided. So you can really override these variables by passing them as arguments to make. So it's something which is quite convenient if you want to quickly check with another compiler what you have. And you can also set it as arguments of configure. So in fact, there are two ways you could. Let's suppose I want to set CXX equals to G++. Sorry, I will make this a bit larger so you can see the bottom of my screen. So I could have done this configure by just setting this variable at the beginning. And so you see it worked. But here, if I look at the config.log, which is the log file of configure, here it appears that I only have configure, so I don't have the memory that I have changed this environment variable before running configure. So if you do it like this, and if you put it after configure, it will have the same effect. Okay, it will have the same effect, but here in the config.log, here you can keep track of this change. So if you want to change environment variables to change the behavior of configure, it's always better to do it as arguments of configure. It's better than changing the environment variables. And also in the configure.help -help, you have here the arguments, the environment variables that you can change. And also you see here that the with and without HDF5 have appeared here. Okay, so that is for standardization. So okay, so before going into Automake, I just wanted to point that usually people use constructs that are for GNU make, but they are not in the specification of make. They are just for GNU make, and so if you switch to another make, it will not work. So if you want to have some software which is really portable, then you need to restrict your expression of makefiles to a subset of what you're used to do. So for example, these pattern rules, this kind of thing, it works perfectly well with GNU make, but if you go to some other implementation of make, it might not work. And so it might be problematic for the portability of your software. And all these special functions, which are very convenient, like this wildcard star.c or patsubst or whatever, they are non-standard. They don't follow the POSIX standard of make. So after it's a choice, you can say, well, I will tell my users that my software will rely on GNU make, or if you want to be really portable, you forget about these pattern rules, forget about special functions, and also the ability to have one rule with multiple outputs, because this is not very well. It's not supposed to be handled by make. So I put here a few guidelines that you should follow if you want to make everything more portable. So forget about the automatic variables, except the name of the current target. Write your scripts with sh. Sorry, that's a typo. I will fix it. So use sh instead of bash, because on some systems you don't have bash by default. So I had the experience on a freshly installed Mac OS. Bash was not there. So also when you put yourself in your make files, the .o files in a separate location than the source files, it will give you more problems than it will help you. So try, because it will prevent you to use these implicit rules of make. Also, well, if you have all these restrictions, if you don't have all these functionalities of make, then it's going to be a nightmare to write your make files. So somebody is speaking. Sorry. No, Evgeny, you should mute your microphone. I think it's you. So yes, so I was saying these make files are going to be complicated to write. So you should instead write some scripts that are going to produce these portable make files. And a good check is to install, for example, bmake, which is another implementation of make. I think it's the BSD one. And you can test your software using bmake, because it's not sure that it's going to work. maybe your makefiles are too tight to GNU make, and bmake will fail. So it's like if you're used to program in Fortran, it's always good to check with G-Fortran and Intel, because they both catch different errors. So trying your software with another make is also a good practice. And of course, use the $make variable in your makefiles, because if you have some rules that call make, if you write make, if you run the main makefile with bmake, then you want also bmake to be run recursively. Okay, so that was just a parenthesis about having things more portable. So the good news is that the makefile, the automake is going to make some, is going to produce for you some makefiles that are portable and that follow these all these standards, and you will not have to do it yourself. Okay, so yes, Lionel, a question.
Have you ever encountered a system less than 10 years old that doesn't have GNU make installed?
Yes, a Mac.
A Mac you have make? You have
No,
GNU make on that?
it's available, but it's not there by default.
Okay.
So it's possible that you log in, or FreeBSD, for example. If you go to FreeBSD, it's always possible to install GNU make, but it's not because it's possible that you always have it, and sometimes you're not root on the system and you don't have access to this. But this was so I agree. After it's a choice. So I agree that you will find GNU make everywhere, and all this what I'm talking about is if you really want to have something that's 100% portable. But if you write in your requirements that your package builds with GNU make, then I think it will be 99% of the time it will be okay. But if you use automake to produce makefiles, then you can lift this requirement to GNU make. Okay, so let's get into the automake section. So let me go back to the top. So automake is this software here that's going to read a file named makefile.am to produce the makefile.in. And you will see it's quite simple to use. So we will here try to introduce this file. And in the makefile.in that's going to be produced, you will have all the standard targets: make all, make clean, make this, make whatever. And you will have your simplified makefile with a few rules inside, and the portion of makefiles that you will have written will be inserted at the proper locations in the makefile.in. And so I was talking about these portable makefiles, but here automake enables the use of the plus equals operator, which is a GNU extension, but here you have it in automake, and so it simplifies the generation of variables. Okay, so let's start now with a minimal working example. So before doing anything, I ask you if you want to store your makefile.in, because what we're going to do is going to overwrite this file without any warning. So I save it like this because otherwise I will lose all the makefile.in we have done in the first part. Okay, so the first thing to do is to inform Autoconf that we're going to use automake in the configure.ac. Configure.ac. And so at the beginning here, after the initialization, I can insert this macro. So it starts with AM because it's related to automake. And so here there are a few options. So the first option is really to say that we're not making a GNU project. because all this was Autoconf was really introduced to produce some GNU projects. So and GNU projects they have very strong restrictions on the fact that you need some news, README, authors, changelog, copying files. And so if you don't put this foreign, then the Autoconf will stop with an error telling you that these files are missing. So here you can use the foreign option. Subtier objects, you should put this when some source files will be located in subdirectories. And silent rules is just to have some less verbose build systems like Christian showed yesterday. Okay. Okay, so that's the first thing to do, is just to introduce this line in your configure.ac. And then, so if we go back to the makefile, you see that what we will need to do is introduce the source files. So here, and a few lines to specify what you want to build. So let me do it. So makefile.am for automake. So here, this bin programs means that the name of the program I want to build, the program I want to build is this, and when I run make install, it should go into bin. Then this test h5 here, I put this name and then I append sources. So this here I put the list of the sources that will be for test h5. So I can put it like this, or I can put a variable, and here I can define this variable. So as you know, the makefile is not something that's executed sequentially. It's a set of definitions, so it's really not a problem to define sources after you use it, because make will start to operate once it has read everything, and it's not sequential. So you can do it like this or like this. It doesn't change anything. And so you see that here this is typically a makefile syntax. It's just a special choice of names of variables, and it's very limited, but that's all we need to do. And then so now we can run the auto reconf. Okay, so here we had this error that some required files are not found, and all these files are files that are needed to use configure with automake. And these files, if they are missing, they can be installed during the auto reconf stage. So if we look at the help of autoconf, you have here this install option that will copy the missing auxiliary files in your project. So you just do autoreconf -i, and autoreconf will detect that these files are missing, and it will install them. So by default, it puts them right here. And so at the end, you will be polluted by lots of files. And so Christian has shown yesterday that with an option, you can tell autoconf to put all these extra files in one directory, so it will avoid to pollute your source environment. Okay, so let's do it simple for now. So we run autoreconf like this. So everything has been reconfigured. The configure script has been produced again. And we have a makefile.in here. So this makefile.in has been produced by has been generated by automake, and we see that there are 825 lines. So it's quite a big makefile. and we can detect multiple targets inside. For example, I can look for the all targets like this. Where is it? Yes, all. There is a make install. So you see, all these rules have been made for you. And now, if you run configure, it will use this makefile.in to produce the makefile. Okay, and now if I run make, it just works. So you see now that using only this this very simplified makefile, you have everything that works fine to compile your package. Okay, so and also you have the make clean that works. Okay, so I was talking about these standard targets. So let's try them and see if everything's okay. So let's try make install. Okay, so yes, so it's not going to work because you see here that it's going to try to install everything in USR local bin, as we said, because the default prefix was USR local. So now I can if I want, create a directory, and I will call like this install, and I can configure -- prefix. So working directory, and then I use this install. So now, if I run make install, it's going to install everything I defined into so this directory, followed by install and bin. And that's the only thing we defined that we wanted to install. So if I look at the install, so here we have install. Inside we have just bin and the test h5 that has been produced. And then I can also make an install just to clean everything. So all this was provided for free by Automake. So it's pretty nice. Okay, so so now we can move on to the next part, which will be creating a distributed tarball. So this is quite important because when you make some software, there are two kinds of people that are going to get your software. So the first one are the end users, the people who just want to download your source code, compile it on their system and run your software. And the second kind of people are those that are going to modify your sources, and so I will define them as end user. The first category as end users, and the second category as developers. So the end users usually they download the tar.gz source distribution, or even sometimes a binary distribution. And but the developers usually they use your Git repository. They make a Git clone, and so they have a different profile. Because if you have some source files that are generated by scripts, the end users will want the generated scripts because they just want to compile. But the developers, they want the scripts that produce the files. So they don't really have the same needs. So if you use Autotools, the great power of Autotools is that the end users don't need to download any extra software, because Autotools just produces some shell scripts and make files. But for the developers of the code, they will need Autotools to be able to regenerate the configure scripts and etc. So it's really two different profiles. So there is a way to tell configure to activate some extra rules in the makefile when you're a developer of a package. So you can use this enable maintainer mode. And I do it like this. So now I can do make maintainer clean. So this will clean. It will do more than make clean. You see, it will do a make clean, but then it will also clean all these extra timestamp files that have been produced, and also lots of cache files for running automake, etc. And it can detect that if I modify the configure.ac, it has to. Oh yes, I don't have. Sorry, I don't have a make. I need to do configure to have a make file. So if I touch to configure.ac now, make will detect that it has to run configure again and auto reconf and do everything for you so that everything will be consistent. So maintainer mode is something that the users downloading the Git repository, it's preferable if they're inside, but your end users don't. So I put a link here for the maintainer mode, and inside I talk about the missing script, because when you're in maintainer mode, you have this script here called missing, and it's just a wrapper to say, well, if I want to use ls, I can do missing ls. Oh, sorry, missing ls. It will work, but if I want a command named Toto, it will tell you, well, Toto is missing on your system, blah blah blah. So if you're in maintainer mode and you're using a command that is not a standard one, then you can prefix it in your scripts with missing, so that you will get a nice warning that something is absent on the system of the developer. Okay, so now you're the developer of the software, and you want to make a source distribution for your end users. So here now you can just run make dist, and here make dist will produce a tar file for you with everything which is required to run make and have the software compiled. So let's do it. So I will make this here, and I have here this Sherman Morrison tar.gz. And so if we inspect what is inside, we have the configure script, we have the M4 extra required script macros. We have the source files that were defined in the makefile. We have the missing script makefile.in, so that if I give this to a user, I expect that the user has everything to run my code. So when you make a distribution like this with make dist, well, Autoconf just produces this file and trusts that it's going to work. So does somebody find an error why this archive will not be okay? So I will give you the solution. You see here that we have the CPP files, but we don't have the header files. So I forgot in my rules to say that the headers are part of the source files. So Automake also provides this make dist check. So if I run it, it will make the distribution. It will run the configure script in a separate directory, and then it will try to compile the code. And you see that if you give your tar.gz to a user and the user makes configure and make, there will be an error. And this is the error we have. And we can say, oh, I forgot to put the HPP files inside my distribution. So yes, of course, they're part of the sources. So I need to change my makefile.am, and I need to provide also the these include files. Okay, so now let's try to make this again. We can inspect the content of the tar file, and we see here that the HPP files have been added. So normally this archive should be okay for user. So let's try it again. So I will make this check. No, and I see there is still a problem. So now I say, well, I have added this HPP file to the makefile.am. It should work. So what's going on? So just by looking at this, I see no such file or directory. So this means that this HPP file hasn't been found by the compiler command. And I see that the directories included here are the local directory, 2 levels higher, and I have here a /include. And the thing is that when make tries to check if the distribution works, make will produce a temporary directory, and so in this directory, so which is this build sub. In this directory, there is no here the place where I put the include files. You see here I put them in Sherman Morrison include. This directory is not accessible here with the -i flag. So the reason is that I need to specify that the include files are in the source directory. So in the srcdir variable. So I need to add this extra flag to the compiler when I am in the makefile .am. So I will do it here. Makefile.am. I need to add this thing, so that if I do an out of source build, I will always be able to locate this include directory. And so now I have added this thing here. I can remove the one which is in the config. .ac. I can remove this thing here. I just got a message from Zoom telling me that my internet connection is not stable. Can you confirm?
Yeah, it's stable now, but just 1 second. We lost 1 second. So.
Okay, so I can replay. so in the configure.ac, now I can remove this this flag because I have moved it in the makefile.am here, and I have added this srcdir variable which points to the position where the source files are. And so if I mentioned here, if for some reason you need the absolute path, you can use the apps srcdir. So now let's run make this check again. Okay. So now we are compiling the files, and now this command tells me that this archive is ready for distribution. So it seems to work. So now, if you take this *gz and you give it to a random user, the random user is supposed to be able to run, configure, make install, and everything should be fine. Okay, so I propose that we have a tiny break now for let's say 10 minutes, and then we will move on to the automake syntax to go deeper into all that. Do you have any questions before the break? No. Okay, so I put the timer on. Okay, so we have only 42 minutes left. So let's move on to the automake syntax. So automake syntax is not very complicated once you understand the rules. So there are some rules that you need to use for variable names. So so there are some main variables that you can use. We have seen the AM Cpp flags, this one, but then you can always use AM LD flags, AM whatever. So all the environment variables that we have seen at the beginning, you can have the same with a prefix by AM here. And so what's happening, look, I will show you for the CPP flags where it appears in the makefile. So you see that to compile C++, then it uses the CXX and CXX flags, but then it also uses AMC. Well, you have CPP flags and you also have AM CPP flags. You have CXX flags and you have AM CXX flags. So it's just once you define these variables inside, it doesn't overwrite the variables that were provided by the user to configure. It just adds some extra flags, and it's separated in two variables so that you can really fine-tune if you want with or without the extra variables. If you define another rule, you can use AM CPP flags and CPP flags together, or you can use only one or the other. So it gives you a maximum of flexibility to define it as another name of variable. So you also have these clean files. Clean files is a list of files that you want to erase when you do make clean. So by default, you will have the default files understood by the definition here. So here we'll have all the .o files related to these source files. But you might want to remove also some intermediate files that you created for documentation or for I don't know what for. So if you produce some files that you want to remove when you make clean, you can add them here. And extra dist will be the additional files that you want also to ship with your binary distribution. Okay, so that's for the global variables. And now we have also what we call product list variables. So so they have this kind of structure. So you will have a list of modifiers, a prefix, and then here we will have the primary target. So here primary can be let's say programs. So we will have bin programs where we have only a prefix and primary. So the prefix can be an installation location. So we have seen here bin, and we can make also the lib libraries, for example. And if you want to have some kind of special structure in your tree, you can suppose we want to do some programs for GPU. We can introduce now an extra directory named GPU here, and we will create a variable for this called GPU dir. And because here we have bin dir, so we have the bin prefix, we have lib dir, so we have the lib prefix. So if I define GPU dir, I have the GPU prefix, and then I can use this location prefix to say the programs that will be in the GPU dir are those ones. And so there are other prefixes that are not locations. So no ints means that you don't want to install these particular programs. Check means products that should be built when you run the test, as we will see below, just like CMake, there is a possibility for testing with Autotools. And extra means products that can be or not built depending on some conditional variables. So that's for the prefix. And now the what we call the primaries. Primaries are the last part here. So primaries can be programs, libraries. LT libraries means libtool libraries. Because there is another topic in Autotools which is called libtool, which is to simplify the development of libraries, but we don't cover it here. Scripts also, because you could imagine that your software also needs scripts to be functional, so you may want to provide scripts with your distribution. Data is all the arbitrary files, documentation, test data, all these things, and headers. They include files to be installed. So these headers are not the headers of the sources; they are the headers that you would provide with a library that should be installed in USR include. So they are the public headers, not the private ones. So that's for the typical. Primary targets, and then we have also the product source variables. So they have a similar template. So modifier list product sources, and so here this is the product. The product is test HDF5, and we use sources. And here you just define what source files correspond. Are necessary to build this particular product. And sometimes you might have some special characters in the name of the product. And when you have a special character, you just need to replace it by an underscore. So suppose you have a libc++.a, then you will have libc++ dot. So plus and dot will be replaced by underscore, and then you put the a. So you need to be careful because you could have some conflicts here. You could also imagine you have a libc ---- and they would have the same same variables here. So you need to be careful about conflicts. Okay, so now you basically have everything you need to be able to write some makefile.am files. And now I can show you the testing framework of Autotools. So this testing framework is supposed to run when you do make check. So I'm going to do it here. We don't have it, so nothing to be done for check. So what we need to do here is to set this test variable, which will be the list of tests to be run. So we're a bit short in time here. So here I wanted to ask you to provide some stupid tests with failure or success. So a success test is a program that runs and exits with code 0, and a failed test is a program that runs and exits with code 1. So if you let me go, yes, in this vision here. So if you go back to the home here there is a link to the final files, and that you should have at the end of the tutorial. And below here you have the success and the failure test files. So you see it's just a stupid file that returns 0 or 1, and that's it. So so I have put them in. I have put them here in the test directory. So you see here the failure and the success. Test failure, just to show you, it's exactly the same. And now what I need to do is to define the tests. So I go back into the makefile.am, and tests. So I say on test success, the success program, and test failure. And now I need to say how I'm going to build these two programs. So I follow the same ideas as above. So I take the name of the program, I append sources, but then I note here that I have a special character, so I replace it by an underscore. And then I tell Automake where to find these source files. So it's so this one is test success, and I will do the same for the failure. Okay, and so now I will run make check, and so I have an error because here the test driver is not found, because when I run autoreconf for the first time with a -i, it wasn't expressed in my makefile.am that I wanted to use the testing framework. But now I have this test variable. Autoreconf is going to find out that it's necessary for me to have this test driver. So I need to do autoreconf-i again, and you will see here that it's going to install the test driver. Installing test driver. Well, variable test failure is defined by the program. Yeah, possible typo. Let me check. Test success. Oh yes, I forgot to define the check programs here. Check programs, so it follows always the same same syntax. It's here the prefix and the primary. So we have seen before that we have this special prefix check. So these are the programs that need to be built only when I run make check. Okay, no error. So now if I run make, nothing has been created. That's normal. But then if I run make check, I will see that the tests will be built. Okay, so the two tests have been produced here, the failure and the success. And so I had test success that passed and test failure that failed. And when there is a failure in a test, then this testing framework stops with an error, and you can look at the test suite.log file to have a report on the failure and see. And here we have the test failure have an exit status of 1. Now you can have also some tests that are supposed to fail, or you know that it fails, but you say, okay, I know that this test fails, but I will fix it later on. So then you can put these failed tests into the xfail, because xfail, you know that it's you don't want to consider this as an error. So then you can add the failure to the xfail tests. And then make check says, okay, it failed, but everything's correct, and it's normal that it failed. So all the tests were okay. And the exit status of this command is 0. And so now you have your tests. What you can do, you can ship your tests with your source distribution package, and then you can make this check to check that your users are going to be able to compile your code, and also to compile the tests, run the tests, and all the tests are okay. So I will do it now. Make this check, the same command as before. So it creates the test. Now it's running the configure in the new environment, compiling the program, compiling the tests. And so if we go up here, we see that the tests have been run also in this in this build sub environment, the tests are okay. And so now Autotools tells you that your archive is ready for distribution. And suppose my tests were failing. So if I do make this check, I would not be able to produce the distribution because the tests are failing. So it's really extremely convenient because here you know that what you give to your users, you have tested it and it's supposed to run. There are cases where the tests can run on your environment, but when you make this check, then you notice that it would not have worked for users, and can save you a lot of email exchange with users and bug fix doing this. So it's extremely convenient. So a few words about package config, because we have talked about this a few times before, and I think that some of you might not know what this is. So I wrote a little section on this. So package config is just a program that will simplify the use of libraries, because you have seen here that when you run configure, you have, if you want to use HDF5, you will have to provide all these flags. So now suppose you're not in this, or you don't have a configure script, but you just want to use HDF5. How can you figure out that these are the flags that you need to use? So package config is done for that. So the idea behind package config is that at the moment where you compile and install the library on your system, you have all the knowledge that's necessary for the users to use this library. And so at this moment, you can save in a file all these flags that they will need to use. And that's what package config is doing. So the package config is producing some simple files, the .pc files, which are usually in a standard place. For example, in USR lib, there should be a package config directory. And if I look inside on my particular PC, that's what I have. And if you look at these files, it's text files with information inside. So if I look at this chameleon.pc, it tells me the prefix, exec prefix, lib, etc., and some metadata. Well, that's interesting to know what this is, and also what are the flags that need to be appended if I want to link with this library. And this file has been produced when I installed this library. And so if I want to access this data, then I can use this command, package config. And if I want to know the C flags, I can just do C flags, and I can use, here we were looking at Chameleon. I can do this. Ah, no, sorry, it was not in the, I have a problem of package config path. So I will export. I think it's probably because of the Conda environment that something went wrong here. So I will use USR lib. Okay, let's try again. Yes, so it tells me that star PU MPI 1.3 was not found in package config source path. So I will not be able to use this. So it was a bad example. Let me try another one. Let's try the core blast. Oh, not better. Okay. So okay, let me try. Yeah.
You can deactivate the Conda environment if you want.
Yes, you're right. It's probably it's a bit stupid. No, it's not because of the Conda environment. It's because these things were not done. No, it's because my system is not well configured. Sorry about that. But so normally what you should have is well, you should have an output like this, where it should tell you what C flags to add and what libs to add, so that if you have just a stupid simple makefile, you can just use a syntax like this to have a minimal working example where you don't worry too much about how you're going to use the libraries. So if we go back at the very beginning of the Sherman-Morrison example, we had the initial one. Oh no, yeah, I lost it. But at the very beginning, that's the first thing we could have done to replace the dependency on HDF5. So it's something which is very convenient. And also, if you're a developer of a library, I would recommend that you produce the packet, the .pc files, because it's very helpful for your users. So I put a few links here if you want to know more about it. Okay, so now it's 12 o'clock, so I think Lionel has a question.
Is there a standard way to produce the files, the package config files?
It's a text file. So the way, so I can show you here an example. So oh, sorry, I'm going to one I have done myself. So the simplest way is that you provide a package config, a pc.in, because you remember when you have the makefile.in, the configure will produce the makefile, and if you have a qmckl.pc.in and you specify it in configure, from this file which takes the variables like this, you can really produce your package config file. So here, by doing it this way, here I specify the prefix that was given by the user when you configure -- prefix, exact prefix, blah, blah, blah. So the name, package name, description, URL. Here for this, I could also take a variable that's already inside the configure.ac, package version, and I know that here I always have to use this -i include dir, and include dir is defined here, and it's given by the configure script. And then the users will always have to add the libdir, which is this one, and then -l qmckl. So basically, what you need to do, I can show it to you here in this particular example. So it's in the configure.ac. Yes, so I just specify that in the AC config files, I have this extra qmckl.pc. So it means that there is a .in file that needs to be substituted with the variables that are going to be found at the configure stage. So just by running configure, you already have your package config file.
Okay, thank you.
Okay, so if you're hungry, then I think it's a good time to go for lunch. And so here I stopped at the point number 8 here. So I put here in the last sections, I put some extra material that could be useful for you. So I will go in 2 minutes very quickly over these points, just to let you know that that is here. And then if you have questions, then I will be happy to answer this afternoon. So yes, the first thing is C definitions, because sometimes you have if-def statements like this. So this section is how you can detect some things in the environment to activate if-def statements. That's something very useful. You can also add some checks to check if some header files are present on the system, because now if you make a grep in the software that we have been used, there is an include to mkl-lapack.h, and so we need to have a check, because this is not a standard header, so it's safer to add a check for this file. And you can, and I put also how you can check for external libraries if you need to use them. So here we have used the macro coming from the macro database of Autoconf, but suppose what you want is not available with this macro database, then you can use the AC search lib and you can write yourself your own macros to do it. And similarly, you can check for external programs. So suppose you have some you want Python to interpret your scripts, then you should probably use a check for Python. So that's what I put here. I put also the few commands that will able to produce some messages from out of configure. The with package, without package, so I give a few more detail here. And this might be useful if you want to have the package configured with MPI or without MPI, for example. You could do this. You would define the have MPI flag, and then in your C program or Fortran, you would be able to use if def have MPI, then I do this. Otherwise, I do the serial part. There's a few words about the Autoscan program. So Autoscan really helps you to look for. It inspects your source. It inspects your configure.ac and it gives you some help about what you could put in your configure to improve it. So it's a very good starting point. If you start from scratch, first run Autoscan and it will provide you some configure.ac to start with. Okay, and yeah, this is, and I put here also an example about how to save the Git hash in a similar way that Radovan has shown yesterday. I provided here how you can do it with Autotools so that you can really have the value of the Git hash inside your program or to print error messages or version or whatever. And at the end, a few links. So I just updated this on my computer, so I will push the changes now because I put some more links for Fortran users. But here I put this link, which is quite good if you want to use CUDA with Autotools. And also when you have the problem of having one command that generates multiple targets, how can you handle that? Usually, what you would do is to produce one single file, which would be I forgot the name. It's a file. It's an empty file where when it's here, it means that all this rule has been executed. So that's a way that you can do. And here I put two examples. So QMCKL, it's just the one I showed you here. It's a library that we develop within TREX. But a better example and more complete is probably the StarPU library because it's a library where they use Autoconf, and they have I think it's one of the best examples I've seen because their configure files are really easy to read. It's very, very clear, configure.ac, and they have many different cases. So they use MPI, OpenMP, CUDA. They use lots and lots of things. And so if you look at their configure.ac, it's really full of checks of options, and you see it's really quite a large configure.ac, and it's really well done. So it could be if you're doing HPC, it could be a good starting point to get inspiration. Okay, so do you have any more questions? So I saw that the Slack was active. And okay, so this one. No. So if nobody has questions, then we can go to eat. And so when do we come back? Let's look at the general. I think it's 12 o'clock, but I want just to be sure of the timetable here. 1:30. So at 1:30 you have the hands-on on your code. So if you can all be there at 1:30 because we will try to make the end of the presentations of the codes. Okay, so have a good lunch and see you at 1:30.